All right. So what is completeness? Okay, so um, the algorithm, the search algorithm, okay, it's said to be complete if at least any solution exists for any of the random input, okay, and it returns a solution. Then that search algorithm is said to be complete. Okay. When we talk about time complexity, it is the measurement of time for the algorithm to complete the task. Optimality is best solution among all other solutions. So if a solution that is found for the particular algorithm, okay, is guaranteed to be the best solution among all the other solutions, then such solution is said to be an optimal solution. And space complexity is the storage required during the search. Okay, space is what? Storage, right? And there are different types of search algorithms. Okay, the first type of search algorithm is uninformed search, and it is also called as blind search. And the second type of algorithm is informed search. Okay, and it is also known as heuristic search. And the different types, this uninformed search is also further categorized. I would say there are different types of uninformed search. Okay, some of them are, there are many more than this. If you like to explore, you can explore it on your own. There are many things available in the site, okay, in Google, so you can search more of them. But according to the syllabus, I am going to cover only this thing. Okay, so first type of uninformed search is breadth first search. Second is uniform course search. Then we have the depth first search, depth limited search, iterative deepening, depth first search, then bidirectional search. Today we will just discuss about the basics of uninformed search and what is informed search. Then we will do in detail only this two: breadth first search and uniform course search. Okay, all right. So what is uninformed search? Okay, so in uh, uninformed search, this search look through the search space for all possible solutions, okay, without having any additional knowledge about the search space. So in uninformed search, as I have written there, as you can see on the screen, it does not contain any domain knowledge. Okay, domain knowledge about the closeness and the location of the goal. Okay, and it includes information only about how to traverse the tree and how to identify the leaf node and the goal nodes. Okay, and it operates in a brute force way. What is a brute force way? It's a way to find correct solution by listing all possible solutions for the problem. Okay, so in this type of uninformed search, okay, the search tree is search without any information about the search space, as I have mentioned. Search space such as the initial state operators and test for the goal. Such informations are not known. Okay, and this is why it is also called as blind search. And the last point about an informed search is that it examines each node of the tree. Okay, it examines every node, each and every node of the tree until it achieves the goal. Fine. Okay. And how about informed search? Informed search, unlike uninformed search, use domain knowledge. Okay. And in this type of search, information about the problem is available so that it can help you through the search. Okay, it can guide the search. Informed search strategies can find a solution more efficiently than uninformed search because you are provided information, right? And it is also known as heuristic search. And what is the difference between this blind search and heuristic search is that in heuristic search, you it takes the current state of the agent as input. Okay, and the estimation of how close the agent is from the goal. Okay, so basically heuristic search is about the estimation of how close the agent is to the goal. Okay, so let's see in detail the first type of uninformed search. You have breadth first search. Okay, so what is breadth first search? So BFS, okay, this is a level um, mm, search. Okay, BFS is an algorithm for traversing or searching a tree or graph or data structure. You might have heard breadth first search in your this data analysis and algorithm. If you have this subject earlier, right? It's the same thing. Breadth first search. It's to traverse the tree, right? And how do you do is you first start at the root of the tree, or it can be any arbitrary node of the graph. Okay, you can start. Um, and what happens once you have initiated the root tree? Okay, you explore the neighboring nodes of that particular node. Okay, you explore all the neighboring nodes at the present depth of 3 using BFS. So let's see what is BFS search. Okay, so for example, uh, let me give one example. Okay, uh, node. Okay, let's say these are the nodes. Okay, so and let's have a queue where we will insert all the nodes that are visited. Okay, in total 1 2, right? So okay, now let's initiate let's choose this as the root node. Okay, this first one as a root node, let's say is. So you'll write this root node here. Okay, and as the definition says, uh, it starts at the root node and explores all the neighboring nodes. Now let's look at all the neighboring nodes. What are the neighboring nodes? Adjacent nodes of 1. You have the adjacent nodes of 1 is 2, 4, and 5, right? So just write 2, 4, and 5. Okay, done. This is visited, this is visited, this is visited, this is visited. So what is the first node that you visited, which is the adjacent node of 1, that is 2, na? So try to explore for the neighboring nodes of 2. You have 7, 6, and 3, right? So just write 7, 6, and 3. 7, 6, and 3. So that's how BFS search is done. Okay, you got it? Let me repeat. You started 1, right? And so you'll write 2, 4, and 5. 2, 4, and 5. Done? Then what is the first node that you visited, which is the adjacent node of the root node? That is second. So you will explore the neighboring nodes of 2. These are 7, 6, and 3. 7, 6, and 3. Done. So this is how breadth first search is done. Now let's look at another example. I'll just use this. Okay. Another example of BFS. Okay. Uh, Yeah, I did not know that I have lost connection. Can you can someone just type it there where I have lost my connection? Okay, okay, I'll do it again, huh? I'll just explain it once again. Okay, okay. All right. Okay, how about the first example? First example is easy enough, simple. Okay, just wait. Uh, all right. Is it visible now, the screen? Hmm, I think so. Okay, so I'll just repeat it once again. I wasn't aware that I have lost the connectivity. Okay, so, okay, first example was this, no? Okay, so you have this nodes 1, 5, 4, 2, 3, 6, and 7, no? Okay, so let's say this is the root node. Okay, 1 is the root node. So according to BFS theory, it says that you have to first explore that current node, right? So you will note down all the neighboring nodes of this particular node. So what are the neighboring nodes of this particular node? You have 2, 4, and 5. So 1 is the node that you're exploring. The adjacent nodes are 2, 4, and 5. So you write it here in the queue. Then what is the first node that you are exploring? Uh, the first node, the first adjacent node of the node that you are exploring, that is 2, no? So you're going to explore that 2 first. 2 has adjacent nodes 7, 6, and 3. 7, 6, and 3. So it has fully filled the queue now. So it means that it has already completed the search. So you don't have to go for in the other um, nodes. Okay, so this is the final BFS uh, search 3 for and this particular tree. And the second example was that you have this 1, 4, 2, 3, 10, 9, okay, 5, 8, 6, 7 nodes. Okay, so for the same thing, you'll draw a queue, and the total number of nodes here are 10. So you'll draw a queue that can contain 10 nodes, right? And my way of solving this is I first write the this queue here, okay, and the neighboring nodes, and here over here I write down the nodes that I'm going to explore. Fine. So let's try to explore this first. Let's assume this is the root node. So 1 is in the queue, and I explored this 1, and the adjacent nodes of 1, the neighboring nodes of 1 are only 4 and 2, right? 4 and 2. So in the next queue, I will have 1, 4, and 2. So whatever is in the queue, you will just write down in the queue. Okay, 1, 4, and 2. And then after exploring 1, okay, you will explore the next node, that is 4, right? 4 The one you are going to explore, just write it at the left side. So 4. Okay. So if you look at 4 in the graph, what are its adjacent nodes? It is having 3, right? 1 you don't have to consider it because it's already visited, right? So you'll ignore that and you'll explore 3, right? So neighboring node of 4 is only 3. So you'll write down neighboring node is 3. And in the next queue, you will have 1, 4, 2, and 3. This will be included, and you can write it, add it up here. Okay, 1, 4, 2, and 3. Now 4 is already explored. What is the next? You have 2, right? 2. Just write down 2. What you're going to explore. 2. Look at the graph. You have these 2. What are the unexplored nodes? You have 5, right? 7. Yeah, I did not know that I have lost my connection again. Can anyone tell me where I have lost my connection? Just wait. No, BFS, I think I have told you. Second example. Okay, okay. I'll just repeat it. Just wait. Okay. Mm, okay, okay. My screen is not getting shared. I'll just wait. Mm, yeah, I think it's getting shared now. Okay, so the second example. Okay, so this is the second example, right? Okay. So you have these nodes, 1, 4, 2, 3, 10, 9, right? 5, 6, 7, 8. Okay, so these are the nodes that you have. Okay, so for this as well, you have to draw this queue, okay? This queue box. The total number of these nodes available here are 10. So I'm drawing a box that can contain 10 nodes, okay? And my way of doing is queue. Okay, at first I make a tabular form, then I write this label neighboring nodes, okay? So first, what I'm going to explore is this node, right? uh, 1. So I'm writing it here under the queue, and as the definition says, you have to explore the adjacent nodes, okay? So the neighboring nodes or the adjacent nodes of 1 are 4 and 2 only, so 4 and 2 I write it here, right? Then in the next queue you will have whatever is here, 1 4 2, 1 4 2, you write it, okay? So, and then 1 is already explored, so and the next node that you're going to explore is 4, so write 4 over here, okay? Then look at 4 in the this 3, the neighboring node of 4 is 3, right? It is 1 also, but 1 is already explored, so you leave it that way, okay? Unexplored node is 3, so 3, okay? Neighboring node of 4 is 3, 3, okay? Then in the next queue you have all this 1 4 2 and 3, right? 1 4 2 and 3. And what are the nodes that you have explored till now? You have explored till 4, right? Next node that you have to explore is 2, right? So write it on here, 2. Okay, so what is the neighboring nodes of 2? Neighboring nodes of 2 are 5, right? 7 and 8. And 3 also, but 3 is already there in the queue, right? So you don't have to explore it again. Whatever is unvisited, you want to write is 5, 7, 8. 5, 7, 8. What are 5 and 7, 8? Okay. All right. So I think it's clear till here. Okay. So in the next node, uh, you'll have one. In the next queue, you'll have 1, 4, 2, 3, 5, 7, 8. Huh? So that's what you're writing now. 1, 4, 2, 3, 5, 7, 8. Okay. Till here, you have explored till 2. So you're going to explore the next. That is 3. So if you look at the graph, okay, what is the neighboring nodes of 3? Look at the graph. Neighboring nodes of 3 is 10 and 9. Okay, 10 and 9. Unvisited nodes, 10 and 9. So you write 10 and 9. And then after that, in the queue, you will have all this and this. So you have all this now. Okay. If you look at the queue, till now you have I think it's clear now. Um, yeah, just look at the board and see there's nothing tough. Okay, and you can find out some more problems related to this and try to solve it. You'll get the answer. If you don't get the answer, then you can give me that problem and I'll solve it. Fine. Yeah, you can search questions like um, BFS algorithm, problem on BFS algorithm. Then you will find lots of questions. Okay, so the next thing that I was discussing was uniform cost search, right? I'll just wait. Uh, I hope everyone is having access to that Jamboard now, so you can just look at that. Everything is already explained actually. Yeah, wait. Yeah, the in uniform cost search, you are given a weight. Okay, I'll just wait. Okay, so you can just look at the Jamboard. In uniform cost search, you have different cost given to you for each edge. Okay, and this algorithm is used for traversing such a weighted graph. Okay, and what is the goal of uniform cost search? Is it is to find a path to the goal node which is the lowest cumulative cost. Okay, optimal path to the goal node. And what is the optimal path? The optimal path would be uh, the um, the path that has the lowest cost to the goal node. Okay, this uniform cost search gives maximum priority to the lowest cumulative cost. As I have said, uniform cost search is equivalent to BFS algorithm if the path cost of all edges is same. Right. Just wait. If you look at the example, just wait. Yeah, so if you look at this example that I have given for uniform cost search, it's not getting shared again. Okay, leave it. Just look at the board. You have this node A, C, B, E, D, H, F, G. Okay. And the thing that you have to do in this problem is to find out the minimum the path that has the minimum cost to the goal node, right? And the goal node is G. Wherever you find double circle, that is the goal node, right? So there are many possible solutions to this. You have this path A, C, D, E, G that leads to the goal node A, B, E, G, okay, A, C, B, E, G. But if you calculate the cost of all these paths, the first possible solution has the cumulative cost 16, ABEG has 14, ACBEG has 12. So you're going to select the least one, the minimum cost path. So you are selecting 12, okay, for this for this problem. Okay, so I saw it in the chat box that someone has a problem with slide number 16, right? Okay, slide number 16. Okay, so yeah, I'll just explain this. You have explored, you first explored this one, right? And its neighboring nodes are 4 and 2, right? 4 and 2. So you'll write 4 and 2, 1, 4 and 2. And after that, what is the thing that you explored? After 1, you explore 4, na? And the neighboring nodes are 3, just 3. So 4 has neighboring node 3, right? So you write 3. Then after 4, you explore 2, na? So you look at 2 and the neighboring nodes are 5, 7 and 8, na? So 2 is having neighboring nodes 5, 7 and 8. So you write down 5, 7 and 8. You'll connect it like this. Then after that you explore 3. 3 is having neighboring nodes 10 and 9. 3 is having neighboring nodes 10 and 9, right? And then you explore 5. It's having neighboring node 6. So 5 and 6 with connected edge like this, okay. And uh, okay, so after that you'll just look back at the original graph, okay. You look at the original graph and there are some connection between 2 and 3, okay, 5 and 7, 7 and 8 and 5 and 8. So you will connect them using a dotted line like this: 5, 7, 7, 8, 5 and 8, okay. So that's nothing, simple. That's all for today. Tomorrow we will explore the um, others. Okay. Anything else? If not, then yeah, you can leave. Sorry if anybody said something. Can you please repeat? I was using microphone, so. There are so many BFS problems available on the net. You can search there and solve it and match your answers. If you don't get the right answer, then you can ask me. All right, that's all for today.